Foundation.
Hi, I'm Veronica. I'm a research scientist here at the Raspberry Pi Foundation.
So, Veronica, since we work on different teams at the foundation, I'm going to use this as an opportunity to catch up with you and ask you, what have you been working on recently?
Yes, nice catching up. And what have I been working on? I'm working on a really interesting research project actually, which is exploring teachers' views on using large language models like ChatGPT to explain programming error messages for students. So we know large language models can generate quite useful stuff, but it also can generate false information, and also its feedback is not always designed with pedagogical considerations in mind. So we're just going to teachers and seeing what they think about it. So it's really interesting and really fun.
Cool.
How about you?
Yeah, I've been working on some of our exciting new AI lessons, in particular with the our ecosystems biology lesson,
Yeah.
and also last week we hosted our first ever teacher panel, which went really well. And the idea is that just gets input from teachers who have been delivering the lessons. So that actually acts as a really good reminder to anybody watching this who's been delivering the lessons. If you have any feedback for us, and please do fill out the forms that we find a link on the lesson plans for, and we promise you we will get back to each and every one of you who takes the time to provide us with that feedback. And we're also looking for new members to join our teacher panel as well. So if you leave a comment in the feedback form that you're interested, then interested in joining us for the next teacher panel, we will definitely get back to you. So without further ado, let's start our third webinar, which is on the topic of the AI project lifecycle. So first of all, we're just going to start off with a reminder of what we offer as part of our Experience AI package of work. So we have a 6-lesson unit, which is an introduction to machine learning and artificial intelligence. All of this is aimed at 11 to 14-year-olds as well. And we have these individual lessons, one on large language models. And as I just talked about there, we have coming soon an AI and ecosystems lesson designed to be taught with in biology lessons. Okay, and then we also have the exciting prospect of a challenge appearing soon. So this is our non-formal offering. So you might do these in your code clubs after school, where you can get your students to build their very own machine learning models. So in the unit of work specifically, if you've been part of our previous webinars, we went through what happens in each one of these 6 lessons. But lesson 1 is an introduction to what is AI. Lesson 2, we explore that relationship between AI and machine learning, and then we look at classification in particular. Lesson 3 is all about the social and ethics side of AI, and we look at bias. Lesson 4 is decision trees, but in this webinar today, we're going to take a deep dive into what we do in lessons 5 and 6 and look at the AI project lifecycle. So Veronica, I believe that we're being joined by a special guest today.
We are indeed. I am very happy to introduce everyone to Ana Salazar. Ana, very nice to see you. Thank you for being here. You're currently working at Google DeepMind, but previously you've worked in other places where you've done work on AI. Could you please tell us a little bit about yourself and the work that you're doing?
Yes, sure. Thank you, Veronica. Hi, everybody. So I am Anna. I currently work as a research engineer, senior lead at Google DeepMind. I am from Mexico. I have a first degree on electronics and a master degree on digital signal processing. I came to London 16 years ago to do a PhD in computer science, particularly on traditional image processing. And since then, I have been working on different tech companies on research and development. That means research to put into a product with a design for final user. One of the companies I work for is for design security document scanners, like passports and visas for the airports. If you have used an airport in Europe or America, you have used my work. But then later on, I work in a company that designs hardware specifically to accelerate artificial intelligence, and we design hardware and software, a whole system for autonomous driving companies.
Cool. That's really nice to meet you, Anna, and a real honor for us to have you on this webinar. And actually, your career sounds really interesting. So we actually have our next webinar on careers, and Anna's going to join us again, so we can take a little bit of a delve into your career path as well, which would be really cool. So you can ask your questions either in the chat or via the form below, and we'll definitely keep an eye on them as we go along to attempt to answer any of them towards the end of the webinar.
Indeed. So as we've mentioned earlier, we're here to talk about the stages of the AI project lifecycle. And we're going to briefly explain them here as they are presented in the lessons. First, we have the defining the problem stage. And this is actually one of the slides that's in the lesson where we present the stage of defining the problem as the stage where we really clearly articulate who is the intended user and what are the benefits of risks and creating a solution particularly involving machine learning, why creating a machine learning model is a suitable approach for solving this particular problem, and what data might be suitable to collect and from where. And at this stage, we encourage a user-focused approach. And by that, where we mean that we take into account the problems the problems faced by users and specifically their wants and needs. So we try and see it from the user's perspective, what might solve their problem. So these are the two slides that we use in the lesson, and there's further information on how to present the stage to the users. But it would be really good to hear from you, Anna, and of your experience of this stage in the AI project lifecycle. First of all, what does defining a problem mean to you? How do you go about it? How have you gone about it in your projects? And what are the factors that you think you need to consider at this stage?
Okay, thank you. So I think defining the project, defining the problem is one of the most crucial parts of a project, especially if we want to succeed on a final user product. But at the same time, it is extremely complex because you want to ensure that you are covering all the ends. This stage usually is done through various runs and discussion meetings with a multidisciplinary team where you have engineers, researchers, designers, architects, test team, product team, marketing, production team. And when you use a user-focused approach, this is an excellent way to go to the final user, for example. In my experience, it comes with amazing surprises. I remember a desktop scanner. This was for passport, which was sold for, I don't know, maybe a few $100s. And with the user experience with marketing, they said there is an interest to have that one in something like ping or have some enhancement or some features. And this is added to the product. And then you create a different thing. So listen your user end is very important in order to develop that. In my experience, defining the problem is very important, but usually you try to first go, and sometimes you have to come back to the definition of the problem.
That's really interesting. So iterate on it slightly. And what do you think, what would you say, how important is the data needed at this part of the project?
Oh, super important. I can tell you right now, we rely a lot on the UX team. This is the user experience teams. This is a specialized team that collects data from the user experience. And they are the ones that feed us back and tell us this is what the experience it is, this is how the problem it is, how we can improve, and how we can make additions and features or create a new product. There is a lot of engineering behind of these user experience teams, because it's not just about ask questions to the customer. It is about to collecting data online and then use this data, analyze it, and come back with these surveys and align that data. For example, there will be user experience like Anna does her shopping on Saturday evening. Let's put the best offers online for shopping groceries because she likes to do it on Saturday evening. Let's put this in the morning of Saturday. So this is definitely data. User experience teams dedicated to retrieve this data, feedback to us, and then we can create the whole cycle again.
That makes a lot of sense. Thank you, Anna.
I find that really interesting as well. I mean, I don't want to jump ahead to our next webinar on careers, but we're not just talking about people who are specialist programmers in making machine learning models. Actually, you talked about this multidisciplinary team of a huge number of people who are involved in creating these products and machine learning models, which I think is really interesting. So I thought I'd show you some of the projects that your students will be able to do in the lesson. So we give students a choice of 3 projects, or you can certainly do that, to pick from when going through the project lifecycle. So we think this is really important. So your students can pick a project that they feel that kind of speaks to them, maybe they're interested in the most. So we have this project on classifying data from the world's oceans. And that's real life data. That's data that's actually being collected from these floats that go around the world's oceans and collect data such as temperature and salinity. So you can get your students to look at this labeled data and create a machine learning model that will be able to recognize where in the world or which ocean this data is coming from. We also have this fake news project. Again, we have pre-labeled data with some fake news and some real news. And your students, again, can train their own machine learning model and test it out with some real news story to see how accurate their machine learning model is in identifying whether or not it's real or fake news. And then finally, we've given the option of this classifying organic and non-organic waste. So again, we have pre-labeled data of images, so some organic waste, some non-organic waste, and then your students can train it and have the opportunity to find some images to use and see whether or not the machine learning model accurately predicts the right class for those that type of waste. So Anna, what do you think of these real life example projects? I mean, have you seen any kind of similar projects undertaken in your experience?
Ben, I need to say I was pleasantly surprised to see the projects. They are indeed very close to a real application, but in a simplified way that is easy to implement, experiment, and really learn the principles of AI. I remember working years ago in a system for face recognition. The first part was to identify faces in a picture. That means classify them, either face or no face. And this is a simple binary classification. So seeing these projects, I can tell you it aligns to the real work applications.
Oh, perfect. Great. So it's really nice to know that the students are taking part in these activities that actually, like you say, aligned with something that actually is a little bit real world. And as they develop their skill sets further, they can explore them in a little bit more detail. Okay, so let's move on to the next stage, which is preparing the data. So I really like this phrase on the slide that we've used at the beginning, which is a machine learning model will only ever be as successful as the data that is used to train it. I think that's so true. And it's that phrase that you may have heard before, which is garbage in, garbage out, which doesn't just apply to machine learning and AI. It's absolutely any kind of IT system that, you provide poor data and ultimately you can't rely the results that they're also going to be not good quality. So that definitely applies to AI. And I think with machine learning models, it's important to also understand that when we take data, it's very rarely going to ever be at a stage where we can just use it to train a machine learning model without doing some kind of preparation to it beforehand. So as you can see on screen here, we've got this data set of some animals in a zoo. What I thought we would have a go at this, and I'm going to put Veronica right on the spot now. Veronica, can you spot any potential problems with this data?
I don't know, but it looks pretty good. It looks pretty well structured to me, although I can spot a couple of missing values in there.
Good, great work. Yeah, so you're right, it is well structured, but we do have some missing values. So you can see I've highlighted there some gaps in our data. Now, if we're creating our machine learning model, we need to decide what we want to do about this, because we don't want our machine learning model making assumptions about what to do with this data, maybe treat it as a blank value of 0. So we have to make some choices as these designers, whether or not we want to maybe remove these items of data, or maybe we want to put the data in ourselves, recapture it again, or maybe put some averages in there. But either way, it's important that we don't leave these missing values in there. There are also a couple of other things to keep an eye on. We have a duplicate entry with our Alexander meerkat. So we have 2 Alexander meerkats in there. So obviously that's going to skew the data slightly and maybe even produce some kind of level of bias in there if we have duplicate entries. And then we also had some invalid data as well. And I really like this one because if you look at the top one there, Bogdan Meerkat, he's got the height of 3 meters. That is like a massive meerkat. So, I mean, I don't know, maybe there is a 3 meter tall meerkat. I'd love to see it if it exists, but the chances are it doesn't. So we've got some skewed data there. And again, you know, if we train our machine learning model with that kind of data, that can cause problems in terms of the predictions and the accuracy of our model. But you know, these kind of data entry errors can happen. It might be the sensor didn't work properly when capturing a set of data. It might be a human error. But again, we need to decide what we want to do with that, whether or not we want to remove that entry or use a kind of like an average of the other heights to train our machine learning model with. So that's all kind of part of this process that we call cleaning the data. The other thing that we need to think about is how we prepare the data in terms of classification and labeling. The projects that your students will be taking in this particular unit of work is all related around classification. So with that, we need to look at our data and decide, well, what are the classes that we want to use and how do we need to label the data? So again, Anna, I'm going to ask you the same question. Obviously, this helps the students to start thinking about the concept that data need to be kind of treated carefully and looked at carefully before training machine learning model. But in reality, what other kind of things do you need to consider?
Well, I would say data is crucial for AI systems. These days, we say you want to succeed in designing an AI system, you need 3 ingredients. Number 1, algorithms. In someone to create new algorithms, that's engineers. Number 2, compute, hardware compute to make the compute of these systems. And number 3, very important, data. And you need to ensure that your data is representative of the problem that you're trying to solve. But data is not always accessible, right? Also, your system contains thousands of samples, and you might expect some noisy samples there. You will need to use techniques to cleaning this data, like filters. These days, it's possible to use AI for AI. It means use artificial intelligence to clean your data, prune your data, filter it, high-quality data, and then use the other data to train further systems in AI. Please let me share a case where the AI system we had, the initial data was playing against the performance of the system. I was working in this company where we received a software that was designed to verify passports to evaluate within the scanners, right? And this system received a picture of a passport and it will verify and identify where is this passport from. Is this passport from UK or from America or from Mexico or from Romania or France, any part of the world? Now, when we were testing, we realized that it was very reliable to identify passports from America. This is 99% sure we'll identify them. But if you put a passport of UK, it was like around 80% reliable. And passport from, for example, from Romania was less than 30%. What was the problem? When they were training the system, the data they have access to, it was mostly passports of America because the system was trained in America. And have a passport or information is very difficult to have access to this data unless you have a partnership with a governmental body that provides you with the data set. So data sets, especially for training, validation, testing, is crucial. How do you clean this data? In reality, right now, we're talking about millions and millions of samples. We're talking about data that each one of us create every day in social media, traveling, browsing. All this data needs to be classified, needs to be filtered before we can actually use it.
Yeah, it's really interesting, isn't it? Because the example we've just used there was kind of a really kind of limited data set of animals. But what you're talking about is, you know, huge quantities of data. So actually using, really like that idea of using AI to help you clean the data as to then be used to create an AI model.
Yeah, and I really liked how you broadened the, I guess, what preparing the data already entails. And it's not just about cleaning it and preparing for an AI model by labeling it, but for example, but also making sure that that data is really representative of your problem and you've got the right data in the first place. So that's really, yeah, it's a really nice broad interpretation. Obviously, in the lesson, we have a scaled down version of what preparing the data means, just to give students a flavor of that. But it's nice to hear about it in real life and what an important stage this is. Thank you. Right. So the next stage after preparing the data is training the model. So we've got the data, we've got the classes. Um, Next, we need to think about training the model. And part of training the model is thinking about the data split. So you've got a data set, but you can't use it all for training. Well, you can, but that means you won't have anything left to test it with. And you can't test it with part of the data that you trained it with, because obviously you've trained it with it, so it's going to do reasonably well. It's already seen that data. You need to test a model with unseen data that it's never seen before. So a real test requires new data. And in the lesson, the students do get to practically train their models using data that is relevant to their project choice based on those 3 project choices that we've seen. And so, Anna, what does it mean to train a model? Can you give us an example?
Yes. So training a model actually means to determine the good values of all these weights and bias within the samples that have been labeled. Of course, we have supervised learning and we have unsupervised learning. That means with supervised learning, we have data that has already been labeled. Unsupervised learning is where you don't have data, but it hasn't been labeled. But at the same time, it's what you just mentioned, right? You have your data set, you have to separate and decide how much of this data you're going to use for your training and how much of this data is going to be used for your tests. And you can contaminate each other, because then you test on data that you use for your training is not giving you a real estimation of how good is your system. It is, again, an art to decide how much of this data you're going to use it for training and how much of this data you're going to use for training. And there are some guidelines, like you have huge amount of data, you can use between 90 to 80% on training and the rest on testing. But if your data is small, you might need to sacrifice some of it and finish with 70%, 60% for training and only 30, 40% for data. But there are other techniques, as you know it, like data augmentation, so you can increase your data for training and that kind of other techniques you can apply.
That's right. That's right. And what are we sacrificing, Anna, when we are assigning more or less data to either the training or the test set? What are the trade-offs?
Okay, so what you want to do is to keep a balance, of course. But there might be occasions where you can't really make the optimal decision because, again, as I said, is the lack of data. So let's imagine in these examples of classifications, your data set is only of 100 samples. You might want to use 80 for training and 20 for tests. If I sacrifice more and I have more for testing, my system will have less information to learn from, will be more data to test on, but will not have sufficient elements to do that. So in that case, like I said, you can do data augmentation. What does it mean? For example, in the case of the classification of images, which is one of the projects here, you put 50%, for example, for testing and the other 50% for training. And each image, you add a feature, a rotation, a compression, any kind of artifact that modifies the image substantially to be compared and say as different sample. For example, a picture of a cat rotated, still a cat. With a bit of contrast, still a cat. So instead to have 50 samples, you might finish with 150 if you do 2 features, or 200 samples if you add 4 different features or rotations, something that makes your data for training bigger. That's a good trick to do when you don't have sufficient data. But of course, you have the luxury of the data of Wikipedia, then you can probably use 90% for your training and 10% for your testing.
Okay, so you have to get a bit creative with the data.
Yes.
Cool. I really like the way you describe it as like an art rather than necessarily a science. It's it's really nice. So is it as simple as just saying that the more data you have for the training phase, the more accurate your model is going to be?
no, it's not only about the amount, it's also about the kind of data or the problem you want to attend. For example, if you want to detect cats and all your data, you have millions and millions of data of cats and all the cats are black, your system was only able to detect black cats. What you need to have is a diversity that embrace the problem you are trying to tackle. In this case, if you want to detect only black cats, yes, have millions and millions of pictures of black cats. But if your aim is to detect cats in general, you better have not millions, only few thousands, but representative of different type of cats, color, and different positions, and then your system will be better trained than narrowing your data only on a specific feature.
Cool. Yeah, and it's what you mentioned before, and Veronica said it's really important that the data is representative of what you want your model to be able to achieve. Otherwise, you end up with bias, right, in the output. Okay, that's great. So let's move on to the next stage. We're flying through this already. So the next stage is testing the model. So we can now assume that we've gone through the process of training our model. So the next stage is to test it. Now, in this unit, we have focused on classification. So if you were here for our previous webinar or had a go at this yourself already, you'll see that machine learning models don't just make predictions, but actually a confidence score is also returned, which you can see on this slide. And in lesson 3, there is an opportunity for you to have a go at creating a model that looks at labels, images of apples and tomatoes. So you can see from this, the model actually has returned the correct label because these are apples, but only with a 58% confidence score. So I suppose we need to make a call on whether or not that's acceptable for the model that we're building and the purpose that we're building it for. Now, the minimum level of confidence is something that we can decide upon, and we call that a threshold level. So in many cases, to understand how accurate our model is, maybe we don't just want to look at whether or not the model correctly labeled the data, but look at whether or not it correctly labeled the data and it's above a certain level of confidence score that we set as our confidence threshold. So let's explore this with a couple of examples. So imagine that you have a machine learning model that predicts the weather in your local area. And you may even notice this on certain weather apps that actually they're quite open and honest about the confidence score that is returned, in particular when it says percentage chance of rain, for example. But I'm going to put Veronica on the spot for this one. If you were making your own machine learning weather app, then what would you set as your confidence threshold for this?
Okay, so the confidence threshold is all about how confident do I want the model to be in order to make a prediction that it's going to rain or be sunny or whatever other weather it's trying to predict. And I like it to be pretty confident. If it's going to tell me it's going to rain, I want it to be pretty confident it's going to rain because I'm going to take my umbrella and my weatherproofs. And if it gives me a lot of false positives where it says it's going to rain and it doesn't, I'm going to probably start losing trust in it and leave my umbrella whether it rains or not at home, and I'm going to get wet. So yeah, I think I would want that confidence threshold level to be quite high in this situation, given that it's not a life or death scenario as well. I think if it didn't tell me that it's going to rain and it does end up raining, probably it's not going to rain too heavily because he wasn't very confident about it raining, and I can always go somewhere sheltered. So yeah, I think I'd say in this case I'd want 80% probably acceptable. I guess as close as it can get to 90, 100%.
Cool. Okay, so you're saying 80%. So if the model kind of said it was going to rain and the confidence score was 81%, we'd say that's okay. We accept that as a positive test. That's accurate. But maybe if it just falls under that threshold, 79%, 75% or lower, then we'll say we won't count that towards an accurate prediction.
Yeah,
okay, I'm on board with that. Yeah, I like that.
Okay, let's swap, Ben. And I'm going to ask you now in a different scenario. In the scenario of a driverless car who's trying to identify pedestrians crossing the road, What do you think about this one? Where would ideally would you want the confidence threshold to be?
I think this is a really difficult question, because I think my natural instinct says, I feel like I want a driverless car to return 100% confidence the whole time, because it feels like it has to be pretty good at what it's doing. But then on the other hand, though, what happens if the model labeled a pedestrian with only 99% confidence? It's pretty likely it's going to be a pedestrian still. So you'd want there to be that to activate some kind of evasive action to put the brakes on or something like that. So maybe 100% isn't, although I feel like that's the right answer. I think actually thinking about it a bit more, maybe it should be lower, less confident. So I'm going to say 60%. That's what I'm going to go for.
Okay.
You'd
want it to be risk adverse, right?
Yeah. Okay. So 60% too high, do you think? I don't know. I'll tell you what. Anna's got experience of this, so I'm going to ask Anna. What's your threshold, Anna?
It's very difficult, especially for autonomous driving. I can tell you in real life, we are all guided by the standards, and these are independently of the companies. These are the standards that say this is the standard for automotive, and this is the standard for airplane, for example. And companies that provide products for either for automotive or for airplanes, we had to follow the standards and the certifications to align to the different countries and rules and laws within different countries. So this is nothing to do with the company. It comes regulated and then aligns to the needs of everybody. But I can tell you that adjusted threshold is like Veronica and you said, it really depends on the application and the risk that you are prepared to take. If your threshold is very high, it is likely that we have lots of false positives. That means that there were samples that were classified negative, but in fact were positive samples. For example, imagine in a passport verification in the airport, you will be rejecting lots of good samples and ask the person, oh, the system doesn't work. Go in queue to the officer verification on that long queue, but you are not taking chances to let pass fake passports. So it's a good reason to have a high threshold in this case. But there will be other applications in where you can afford a lower threshold. For example, imagine classifying green and red apples. Someone might finish on their grocery shopping with red apples when they order green apples. So it's not that critical, right? So you can afford a different kind of threshold. A good way to do it is when you explore this on a raw curve. That means you start to set your threshold from 0 until 100% on little steps like 5%, 10%, 15%, and you constructing this curve of true positives and false positives. And then you decide where would you like to operate. This is typical. This is something that we do. That said, need to say that in real life, what we do is we construct different rock curves under different conditions. For example, the same system under certain extreme temperature, like minus 20, a rock curve under 50 degrees, temperature, pressure, lighting, different conditions. So you finish with more than one curve, you finish with lots of curves. And then you try to extrapolate data from that and take your best decision for the threshold.
Cool.
Those are really nice examples. It's not the most intuitive concept to grasp, so I think those are really nice examples to understand it with.
Cool. So, should we move on to the next stages, Veronica?
We should. The final two stages of the AI project lifecycle are the evaluation and explanation stages. First, we evaluate the model. So we consider what factors we might want to take into consideration. For example, was enough data used? Was it representative enough of the possible scenarios which we're trying to solve in the real world? Is there any bias in the data, in the training data, that we need to communicate or mitigate against? And what are some of the limitations of the models, because ultimately no model can be perfect and can do everything. But it's important to communicate those limitations. And one way to explain these models and document the results of an evaluation is model cards, is using model cards. And model cards are a way of documenting information about a model, including a small description about it, the type of data it takes in, information about its performance, how well it performs in real life. And importantly, it also documents the model's limitations. So, for example, in this case, we have a face detection model, which its limitations include not working so well in crowds, so where the face sizes will be small, depending on it's not works really well depending on the facial orientation. So if someone isn't looking straight towards the camera, in poor lighting conditions, when the faces are occluded or blurred, or the faces are in motion from video streams. So these are all important factors to take into consideration if you're considering using this face detection model.
So you say this is an actual real model card, Veronica, that exists in the real world?
It is indeed, yes.
Cool, because I think it's really interesting. I think this concept of being transparent feels like really important. I mean, I was just thinking as you were talking about the driverless car example. So before I was going to get into a driverless car, or maybe I was creating a driverless car and I knew these models existed, I think I would like to know a little bit more about it. For example, we've talked a lot in this webinar about representation of data. I'd be really keen to know that what images were used. Was it representative of all the pedestrians you have crossing the road, whether or not they be tall or short, or maybe babies in prams or people in mobility scooters, or even where in the world, right? Because I think streets in certainly where I live look very different to streets in like London or maybe in another country in the world as well. So yeah, I think it feels like transparency is the right way to go with these things.
Definitely. And yeah, like I say, I don't think any model is perfect. It can be perfect and can cater for absolutely every situation. So knowing which situation is best suited for, I think it's really valuable.
So in the lessons, we actually have a practical example. So the model card that you just showed there, we actually want you to give this to your students to explore themselves. So they get the opportunity to look at this model, but then evaluate it for a real world purpose. So we give this context as this music venue that hosts concerts that want to create an application that will help them with crowd management. And what they want to do as the user of this model, they need to know how many people are gathered in certain areas to avoid overcrowding. So maybe, Veronica, we should have a look at this model again and decide whether or not we think it's appropriate to use for that context.
Yeah, I mean, given the limitations, it outlines the fact that it's not great in crowds where the faces face sizes might be small. People not always look at just in one direction. I mean, concert venues are known the lighting's not going to be good. People move around a lot, so it doesn't look like a very good model to use for this particular context, does it? Although saying that, I think, again, if I was a concert venue looking potentially to use a model and I didn't have any other better suited models, I might look at how my cameras are set up to then make the model more suitable for my context, maybe. So it might be worth testing. But again, testing with knowing these limitations will make my testing really easy, because then I can test around these specific limitations and see how limited is it really.
Yeah, that's really interesting, because I think I was looking at it going, well, the lighting issues and the face orientation, they feel like big kind of drawbacks to be able to use it for this context. But I think you're right. It doesn't necessarily mean that you can't use it. But I think knowing about those limitations really helps me make, the kind of decisions that I want to be able to make, whether or not it's just a pure no, or whether or not we can think about other ways or places we can put our camera and test it out. So I think that transparency is going to help you make that decision, right?
For sure, for sure. I think so. Anna, what are your thoughts around kind of the use of model cards, maybe use them before, and the importance of transparency for AI models?
Yes. Firstly, apologies because the light went off. I'm really sorry. I think it's like you said, right? The transparency, the information is the way to go. Documenting your work by any means is very important. In this case, having a written reference enable not only the potential of using your work for other people, but also imagine that you want to revisit that work in a few months later, so you have a reference. So rather from starting from scratch, you can say, oh, that model was training on that data, had these limitations. Having a model card is very important. I will add other fields like which kind of technique you use it. Classification using convolutional neural networks. Do you use transformer unsupervised, and then on the top of that you do some fine tuning? Do you use how much data? So the most merry in this case that gives authentic taste of what is this model about it, what are the limitations, and then there might be a use case that is narrow and specific where your system, despite of all the limitations, will be useful. Talking about of the limitations of the camera sensors, years ago, I remember a system that was very reliable to detect faces of people with white color skin, but they had limitations detecting and recognizing faces of people with dark color skin. So this was very, very important because companies start to design better sensors that were specifically designed to capture features with more sensitivity to do it. These days, what we have as a face recognition on the mobile phones is using not even images, not even the image, but they use a system of LiDAR where it basically does a 3D map of your face. And it's very simple system because it's Anna or it's no Anna. It doesn't recognize other faces, right? Just Anna and Anna. And each time I use it, I'm training it again and again and again. So
Wow.
if your mobile phone, which has been with me 2 years, each time I unlock it with my face, it's another training, right? It's another reassurance that is me, and it becomes very reliable with the time. So that's another way to do it, not relying on the camera sensors, but relying on other kind of technologies like LiDAR, for example.
Cool. Great. Okay, so I think we have now been through all the stages of the AI project lifecycle. So yeah, well done. So as we've been through everything, I think we should take a look to see whether or not we have any questions from anybody who's been watching along. Don't forget that we have the feedback form and the chat. If you've got any questions now you've watched all of this, if you want to, now is your opportunity to ask us or Anna some questions. But I don't know. Let's have a look. Did we have any questions? So perfect. So one of the questions that I can see has come through. Veronica, I wonder if you can answer this one. It says, what are the key points in the lesson that are worth spending a little bit more time on, do you think?
Yeah, it's a tricky one to answer. I mean, everything, but also, I think we maybe talked quite a bit about that idea of the confidence threshold and how perhaps it's not the most intuitive concept to grasp. And I think it might be worth spending a little bit of time and going through lots of examples with students to really kind of understand that. And I think it's perhaps less about the exact confidence threshold that students choose, but more about kind of the ability to explain why they've chosen the confidence thresholds that they've chosen. So what examples have they thought about? Have they thought about that kind of that risk adversity or the risks they're willing to take in the model making certain predictions? So yeah, I think and the other kind of nice idea is depending on the choices that the students make for their project, it might be interesting to get them to talk to each other. So if for the students that have chosen, let's say, the fake news project, can they talk to all the other students who have chosen the same project and say, hey, what threshold have you chosen, and why, and sharing insights in that way, because as Anna has also mentioned, like getting different people's perspectives into the design of the model is so important. So yeah, that's potentially a nice way of going about that justification.
Yeah, I really like that idea that you just described there, where if you've got a class full of, I'm imagining a class where maybe a pocket full of students have done that fake news one, or whether or not they kind of just, they talk it out together and be collaborative, because it's almost what Anna was talking about before, they're creating a team almost. And as we talked about before, I think having people with different opinions and different experiences always helps the outcome for a machine learning model. So yeah, I think you're right. I think it's not so much about whether they come up with an exact correct answer. Much like the training and testing data split, it doesn't really so much matter what they which percentage they pick, as long as they, like say Anna said, it's not an exact science, it's an art. So just picking a starting point is a good place. And if they look at that and think it's had an impact on the accuracy, and they can go back and train again with a different percentage and compare those results, I think that would be a really good outcome if they can see the difference in the accuracy of their model by playing around with the percentages.
Definitely.
Yeah. Okay. Great. So I think we don't have any more questions. So I think we will probably wrap that up then, Veronica. Our next webinar is on the 29th of November. And as I've alluded to before, we're going to be talking about careers, and Anna is going to be one of our guests again. And we've got a couple of other people joining us to talk about their kind of route in and their experiences working in the world of AI.
It was very nice
Thanks
to see
very
you,
much
Anna.
for joining us, everyone. And and Anna, special thanks to you for coming to joining us. It was a real pleasure having you, and definitely adding value to the adding extra depth to the lessons that we're trying to deliver. So yeah, thank you very much.
Actually, I want to say thank you to you to make me part of this experience. It's the first time I'm doing this. I hope all the students enjoy the project. I think this is the start, right? Is that creating these first models has the first experience. And from there, once that they have the model and they start to play and they start to experiment with the model, I would say the students need to Google it. What's next, right? How can I play? How can I add more features? And there is a lot of resources and data these days in the internet that I hope they explore more and more and more. I remember my son, when I gave him as a project to a sort for 3 numbers coding, just sorting 3 numbers from the smaller to the highest. He was, oh, good. What's next? And I said, do it for 5. Oh, good. What's next? When I went to 11, he said, this is difficult. And I said, yes, it is. Right? It's that exploration. So I think this project is fantastic. Is the first AI experience that hopefully we'll see lots and lots and lots of people enjoying and exploring in a different way. Thank you for that.
No problem. It's, like I said, I know it was great to have you with us. I'm looking forward to having you on the next webinar as well.
Very
okay,
nice.
Right. Yeah, nice to see you, and thanks everyone.
Nice to see you. Goodbye.
Bye everyone.